Good evening, everybody. Thank you for attending another Gleneagles University lecture series. I can't even tell you how excited I am to have finally have this company and this person, Jeff, to talk about the future of electric cars and of course, but mainly the solar car. I don't know how many of us, we've spoke about a lot of electric vehicles. We talked about charging stations, but now today we're going to talk about solar electric cars and just powered by the sun. And I've reached out to Aptera, the company that we're going to discuss today. I think just about 8 months ago, I've been fascinated with them wanting to go green, trying to save the environment. Every So I've been following them for a long time and been pestering them to find me somebody to talk to you about their products and what it means to our future generations. So what they did is they found me this great man, Jeffrey Penzinger, and he's actually a
Petsinger.
mechanic. Petsinger. He's
Hmm.
actually a mechanic. He's an brand ambassador for Aptera, and he's also a mechanical engineer, if I'm not mistaken. And he knows everything about everything. And he is so passionate about Aptera. He wants us to make him famous so they'll hire him so he can work for them directly. But let's not put that out there. But anyways, I really want to I want to thank everybody for coming today, and thank you, Jeff. It's all yours.
All right, thank you, Tammy, and thanks for having me tonight. First thing, I think you kind of hit on the head there that is a separate category to talk about solar electric cars because cars can't really be powered by solar unless they're highly efficient. Otherwise, it's just kind of like a marketing gimmick to put some solar cells on there. So, I'd like to get started. The share screen. All right. I'm not an employee of Aptera, as Tammy said, but I am an enthusiast of the car, the technology, and the company's goals of helping the environment by designing the world's most efficient solar car. My personal background is I have a master's degree in mechanical engineering, and my enthusiasm for this car stems from the observation that, in my opinion, the Aptera team is just doing everything absolutely right. In fact, Aptera started out as a car that one of the founders, who also has an engineering background, wanted to design for himself to make his California commute a little less expensive and more environmentally responsible. In my opinion, this car is nearly perfect. It's a study in extremes. It exists to demonstrate what can be done when the best materials and design principles are used and given priority over the focus groups and marketing professionals that drive the design of most cars. In the next few years, there's going to be a lot of electric vehicles coming to market. And over the course of this presentation, I hope to convince you that this car is truly special and unique and completely different from anything on the road now or in the pipeline in the near future. Tammy, you want to help me again?
It's just like your PowerPoint. It's a PowerPoint, so you just have to hit your arrow
It's not
to go to the
advancing.
next slide. Okay, so just minimize. You can take it away from full screen. Is Okay. There you go.
Okay. So a good question to ask ourselves is, why are we moving to electric vehicles? I think for most of us, I think the answer to that question is usually we're trying to help the environment. The internal combustion engines, or ICE for short, only extract about 23% of the energy in their fuel, with the rest getting converted to heat. There's concern over rising temperatures and sea levels, and I think some of you probably witnessed that firsthand down in Florida. If we can use energy more efficiently and reduce the amount of carbon added to the atmosphere, we may be able to slow the rise in temperatures. Also, since there's a finite amount of oil, we pretty much began running out the day we started using it. There are some things that probably always will require the use of petroleum fuels, and I think it'd be wise, to conserve those fuels for those applications. Also, electric vehicles lend themselves to being charged by renewable energy sources, preferably rooftop solar panels that reduce the line and conversion losses traveling from the power plant to the point of use. Aptera has taken it one step further and generates the power directly on the car, which is as good as it can get. But if you think about it, if we're trying to help the environment, if we're not trying to help the environment, why would we change from ICE cars? I mean, they're working fine. There's a well-established infrastructure. We don't need to move away from them unless we're trying to do something good for our children and grandchildren. And if that's truly the goal, then it makes sense to buy electric cars that are efficient and use as little energy as possible. And as you'll see, not all electric cars are efficient. Just because a car runs on electricity doesn't mean that it's an environmentally sound choice. Aptera's made some bold claims about the range and efficiency of their car that are often met with disbelief because they're just so good. The goal is to convince you that these claims are real and explain how they're possible. The Aptera is 2.5 times as efficient as the closest competitor using only 100 watt hours of power per mile. This means it can travel almost 3 times farther on the same amount of energy and consequently requires a battery 1/3 the size of other electric vehicles, which translates to a lower price and a longer range. The Aptera can travel up to 1,000 miles on a single charge, depending on the size of the battery that you would choose. It comes in 4 range levels, 250, 400, 600, and 1,000 miles, with the 400-mile version being the most popular. The onboard embedded solar cells can collect up to 40 miles of range per day from the sun, depending on the configuration of the solar package and the geographic location. Since the average commute is about 29 miles, this means the average person may never have to charge their car for daily use. Living in South Florida, as you do, just by leaving the car in the sun, I think you all could expect 40 miles of free cruising range up and down A1A every day. This is a slide shows the spectrum of efficiency of various vehicles. On the left, you have the mining dump truck, which is there to provide some learning at one extreme. Next in line is the Hummer, which occupies the category of all large trucks and SUVs and other heavy, wildly inefficient ICE vehicles with the aerodynamics of a barn door. From there, we move through the more common categories of ICE cars until we reach the hybrids and the Tesla Model 3. One thing I'd like you to notice how similar all of these vehicles look, including the Tesla, until you get to the Aptera. The Aptera looks radically different because its design is driven almost purely by science and physics. As a result, Aptera will likely occupy the position of highest efficiency of all cars on the road today and into the near future. Personally, I've already begun regarding most of the cars I see in the parking lot as looking like horse and buggies already, hopefully to be soon replaced by cars with the same design ethos as Aptera. This slide's somewhat of an eye chart, but it does a nice job of compiling the watt hours consumed per mile of all EVs in the US currently. The Tesla Model S Standard Range Plus is the current king of efficiency on this chart, but still uses an average of 237 watt hours of battery power per mile. Just above that, you can see a blue bar for Aptera for comparison. The Aptera will use less than 100 watt hours per mile, making it almost 2.5 times more efficient than its closest competitor. In case you're wondering which car occupies the last place on this chart, it's the Rivian R1S electric SUV, due to hit the market also in 2022, consuming up to 518 watt hours per mile. That is more than 5 times less efficient than an Aptera. While all electric vehicles are a better choice for the environment than a typical ICE car, many car manufacturers are stuck in the old design paradigm and have not yet asked and answered the question of why we're moving to electric vehicles. To a large extent, both new and old car manufacturers are still designing electric cars with old materials and assembly techniques with minimal emphasis on efficiency. The Aptera uses a first principles design philosophy driven by the relentless pursuit of efficiency. Aptera's engineers begin with assumptions that can't be deduced any further and are known to be absolutely true. In the case of a car, efficiency is an absolute truth, and it breaks down into three main categories. The car must be lightweight, aerodynamic, and make efficient use of its fuel. To that end, Aptera uses a lightweight composite monocoque shell composed of fiberglass, Kevlar, and hemp fibers held together with high-strength epoxy resins. The suspension is composed of lightweight steel and aluminum, optimized with artificial intelligence-driven generative design for maximum strength and minimum weight. The end result is a car that weighs only 1,500 to 1,800 pounds, depending on how it's configured. Of course, the most obvious difference is the shape of the Aptera, which also has been optimized using computational fluid dynamics to reduce the drag coefficient to 0.13. This will be the lowest drag coefficient of any production car on the market by a considerable margin. The drag coefficient is like a golf score, the lower the better. Aptera uses much less power to push itself through the air. Some ancillary benefits of this are that it is extremely quiet inside the car at highway speeds as you're moving down because the wind isn't buffeting the body as in most cars. You also get no bugs stuck on it since they tend to just flow right over the car. The Aptera uses 2 or 3 motors, which eliminate the weight and energy losses of a traditional drivetrain. This opens up new possibilities in traction control and immediately gain 25% efficiency over a four-wheel car simply by eliminating the rolling resistance of one wheel. This is a video of air flowing over the surface of the car generated by simulation software. For Aptera to achieve the lowest drag coefficient of any production car, they've placed a huge emphasis on the aerodynamics. The shape is actually modeled after that of a shark cruising along the bottom of the ocean. It was noticed that sharks arch their backs in order to direct the flow of water up and over their bodies to make it easier to swim close to the ocean floor. Aptera used computational fluid dynamics to discover and evolve the shape to where it stands right now. To illustrate how much traditional car manufacturers have ignored aerodynamics, the drag force generated by the entire Aptera car is less than that of just one side view mirror on a Ford F-150. 6% of the energy consumed by the average car is used to push air out of the way. Aptera's founders realized this was a huge source of efficiency that could drastically extend the range of an electric vehicle and a perfect example of low-hanging fruit that other manufacturers have largely ignored. The Aptera is 50% lighter than a similar sized traditional car due to the use of lightweight composite materials and weight and strength optimized suspension parts. The final weight's hovering between 1,800 pounds, depending on how it's configured. For comparison, the Tesla Model 3 is coming in 3,600 to 4,200 pounds. This means the energy used to accelerate or propel the Aptera up a hill is greatly reduced. The low drag and weight both contribute to a 0 to 60 sprint time of under 5.5 seconds for the two-motor front-wheel drive version and under 3.5 seconds for the three-motor all-wheel drive version. And finally, the composite monocoque construction and airbags make the car extremely safe. Aptera is using hub motors that take advantage of the unused volume inside of the wheel to house the motors. Compared to a centrally located motor, this eliminates all of the drive shafts and couplings required to bring the power out to the wheels. Getting rid of those drivetrain components reduces the weight and cost and increases the efficiency and reliability. And of course, the same energy savings apply to the energy captured through regenerative braking. Each motor has an encoder built into it that accurately monitors the rotation of the wheels, and this has huge implications for stability control, braking, power steering assist, torque vectoring, and autonomous driving features. Other manufacturers such as Tesla and Lucid have developed amazing electric motors with spectacular power to weight ratios. However, in order to be efficient, they have to run those motors at very high RPMs, meaning they have to be coupled to a heavy, complex, and expensive gear train that can waste as much as 15% of the power generated by the motor just in friction losses. Motors are heavy components, but in Aptera, that weight is concentrated as close to the ground as you can get and applied directly to the wheel pad. People who've had the privilege of driving one of the Alpha prototypes report that it drives like a traditional four-wheel car, but there's an additional sensation that the car is really planted on the ground. Furthermore, placing all of that weight so close to the ground lowers the center of gravity of the car, which contributes to excellent handling. By the way, hub motors look like they will be the future for many electric vehicles, and Aptera is already there. This slide focuses on the efficiency of a few common cars that you may already own or are on the horizon. The efficiency index is simply how far can a car go on the size battery it has. It's measured in miles per kilowatt hour, but this data has been normalized for a 1 to 10 scale, so with the winner being a 10 and all others being some number less than 10. The beauty of this number is that the inputs to it are so simple, it's hard to really dispute the outcome. As you can see, the Aptera is about twice as efficient as the Tesla Model 3 Standard Plus. This isn't really surprising given the Aptera's extremely low drag coefficient and weight. I think the one valid argument against this index is that all the other cars on this list are four-wheel, 5-passenger sedans. This adds some rolling resistance and size and versatility to those cars. The picture gets even worse if you start to compare it to electric vans or trucks, since it's truly an apples and oranges comparison. But if you're single or retired and there's only one or two of you, the Aptera probably will serve your daily driving needs quite nicely. The performance index is a category I didn't expect the Aptera to win. I thought it would do well, maybe come in second or third, but it managed to edge out the Tesla Model 3 Plaid. And I admit that just doesn't sound right, but I've shown how I calculated this index by multiplying the range by the top speed and dividing by the drag coefficient, the 0 to 60 time, and the weight. Of all the comparisons I did, this is probably the most subjective because it depends on how much you value each of the particular variables. The Tesla Plaid is where it is at almost purely on the strength of its neck snapping acceleration and top speed. Aptera has very high range, but is software limited to 110 miles per hour. The Tesla has decent range and a much higher top speed, a decent drag coefficient, and a ridiculous sub 2 second 0 to 60 time, and a weight somewhere north of 2 tons. It's a drag racing monster, really. However, in my opinion, most of us don't have a lot of reasons to accelerate from 0 to 60 in under 2 seconds or drive 200 miles per hour. I've accelerated in a standard Model 3 in normal mode, found it to be uncomfortable. Pushing the Plaid to its limits practically requires a G-suit to avoid blacking out. So regard the Aptera as having a nice balance of performance attributes with very high range, a reasonable top speed, extremely low drag coefficient, a 3.5 second 0 to 60 time, which is really nice, and extremely low weight. I would have liked to include some skid pad data in this calculation, but that's not available yet for the Aptera. But the weight is somewhat of a surrogate for handling. Category that Aptera really excels in is value. Value is simply defined by dividing the performance index that was on the previous slide by the price. For the Aptera, I priced it for the 250-mile range, all-wheel drive version with the full solar package, and use the MSRP of the base models, the other cars listed on the internet. It really isn't worth doing a deep dive on the details of this calculation because the Aptera delivers 5 times the value of the Tesla Plaid and the Model 3 Performance. I don't know about you folks, but I'm a value buyer. I rarely find myself buying the most or least expensive of anything or the highest performance of anything. I'm always shopping for a best value. And if your purchasing philosophy is the same as mine, there's just no doubt the Aptera is an outrageous value. I promise this is my last bar chart. I promise this, the composite score is simply the sum of the efficiency, the value, and performance. Once again, the Aptera just nudges out the Tesla Plaid, and the Plaid is there almost exclusively due to its high rate of acceleration. I think it's interesting that the Lucid Air is in the hunt. The Lucid Air is an extremely luxurious electric sedan, and in my opinion, more luxurious than the Tesla. If I were in the mood to spend a lot of money on an electric sedan, the Lucid Air would definitely be on my short list. The Aptera is admittedly a completely different animal than the Tesla Plaid or the Lucid Air, but again, it all depends on what you value. Seeing as though the Tesla Plaid scored so well, I thought it was worthwhile to take a little closer look at the specs. The Plaid gets up to 396 miles of range, which is really decent considering the weight and overhead of all the motors it's carrying around. It can generate 1,020 horsepower, which is just crazy. That corresponds to a 0 to 60 time of 1.99 seconds and a top speed of 200 miles per hour. It's just a monster. It has a yoke instead of a steering wheel, which looks really cool, but a lot of people find it to be impractical. This is a very, very good car, but it should be for $125,000. The Lucid Air Dream Edition is an impressive car and scored close to the Tesla Plaid in many of the figures of merit. It has 471 miles of range, with some versions going up to 520 miles with a 118 kilowatt hour battery. For a quick comparison, the Aptera would travel over 1,200 miles on the same size battery. It generates 1,111 horsepower, which is slightly more than the Tesla Plaid's 1,020 horsepower. It sprints to 60 miles per hour in less than 2.5 seconds, which is amazing, but still significantly slower than the Plaid. I think the extra 284 pounds of weight the Lucid Air is carrying around might be the cause of the slower acceleration. The Lucid Air Dream has a top speed of 168 miles per hour compared to the Tesla Plaid's 200 miles per hour. I don't think the acceleration or top speed of either the Lucid or the Tesla are practical criteria to prefer one over the other, since few of us will ever have any reason to use their full capabilities. In my opinion, the Lucid Air is a much more luxurious car than the Plaid, and the glass roof is really cool. You've got $169,000 burning a hole in your pocket, and efficiency or environmental responsibility are not at the top of your list. The Lucid Air Dream Edition is a pretty nice car, although Mercedes S-Class is only $111,000. There are a couple of cars out there that have solar cells embedded on them, and it's really worth taking a look at them because they more closely compare to the Aptera. The Sono Scion is a German car that's also slated to come out in 2022, just like the Aptera. And it has embedded solar cells, and it's one of the few cars that I know can generate a meaningful amount of daily range from those solar cells. It does have the advantage of being a 5-passenger car. The solar cells on the side of the car are at a less than optimal angle to absorb solar energy. Indeed, it only manages to generate about half of the range of the Aptera per day. The 35 kilowatt hour lithium phosphate battery has the advantage of being an older, more stable chemistry, but it's also heavier and less energy dense. It has almost half of the horsepower of the three-motor Aptera and turns in a pretty pokey 0 to 60 time of 8.8 seconds. Its top speed is only 87 miles per hour. I was not able to find a drag coefficient for the Scion, but I think it's pretty obvious from looking at it, it's not in the same class as the Aptera. At $29,000, it's more expensive than the lowest 250 mile range version of the Aptera and worse in every performance category except that it can carry 5 passengers. I can see this car appealing to a certain segment of the population that values the utility of the vehicle. But aside from that, it's really not very impressive. The Lightyear 1 is probably the closest to Aptera in terms of performance in the category of solar-powered cars. They claim they'll be able to get up to 45 miles per day from the solar cells, which is slightly better than the Aptera. They claimed 450 miles of range on a full charge, which is in the middle of the Aptera's range capabilities, but pretty good for a 5-passenger sedan. Its performance is pretty poor, due to at least an additional 1,000 pounds of weight over the Aptera and a little less horsepower. It has a relatively slow 0 to 60 time of 9.9 seconds and a top speed of 93 miles per hour. This car is decently efficient, but it lags in performance, and based on its very high price, it's really a pretty poor value. I think this car is significant mostly because it shows that a 5-passenger sedan can be designed that can collect enough range from onboard solar cells to meet most people's daily driving needs. It's just the high price. It really puts it out of reach of the average person. Oh no, not another bar chart. Let's take a look at the 3 cars that most directly compare to the Aptera in those same categories of efficiency, value, and performance. And as you can see, once again, Aptera is winning all 3 categories and very strong in both the value and performance categories. It's really stacking up very nicely against all of its competitors. Tammy mentioned that you might be interested in the history of Aptera and know a little bit more about the founders. Unlike most startups who, true to their name, just start up, Aptera has been around for a while. They were founded in 2006 by Steve Fambro, who was originally known as Accelerated Composites. Chris Anthony joined shortly after as the COO. They changed the name of the company to Aptera and pursued a gas-powered car with a 330 mile per gallon range. In 2008, they hired some car industry veterans to steer the company into production while simultaneously pursuing government loans. They were denied the loans because their design had 3 wheels and wasn't considered a car. In 2009, the car was featured in the Star Trek reboot, driving through the scene in the background. It was also featured on Jay Leno's Garage, and that video is still available on YouTube if you care to check it out. By the way, there's a new video of Jay Leno driving one of the more recent Alpha vehicles that will be released soon. By 2011, the founders had left the company because it had headed in a direction that was just very different from their original version. Aptera went out of business and returned everyone's deposit. In 2012, the intellectual property was sold off to a Chinese company called Zhejiang Jianwei and then went silent for 7 years. In 2019, the founders bought back the intellectual property and started Aptera Motors. Now in 2021, they've produced 3 Alpha vehicles, have begun tooling and assembly of their Beta vehicles, and are on pace to deliver a production intent vehicle by the end of the year and begin production in 2022. I think it's encouraging that the founders so firmly believe in the concept of Aptera that they came back after an 8-year hiatus and restarted the company. Both of the founders of Aptera are serial entrepreneurs. Steve Fambro built an ultra-efficient farming platform based on hydroponics. Chris Anthony built two businesses, one in lithium ion batteries and Epic boats, both of which gave him relevant experience for their current work at Aptera. Both of these guys are very risk tolerant. That's not to say they're reckless. They just have a high tolerance for taking calculated risk to do things better in areas that they think they can help the world live better. So many industries are stuck in a monkey see, monkey do mentality, just doing things generally the same way as their competitors are doing them, with only small differences between them. Both of these guys looked at the current state of ICE cars getting bigger and heavier and less aerodynamic and saw nothing but opportunity. Neither of them could believe that so many good technologies and design approaches had been totally ignored by the major car manufacturers, both in car design, materials, and manufacturing techniques. Watching a truly unique car come to market at record speed with minimal capital investments, I think really validates their approach and their ideas. Any discussion of electric vehicles would be incomplete without talking about batteries. I have to begin by saying I'm not a battery expert. I'll just kind of report what I've seen out there. The current best technology for electric vehicles is a lithium-ion battery with a liquid electrolyte, which is different from solid-state lithium batteries, which I'll discuss later. Although they're very energy dense, they're temperamental little snowflakes that have to be protected from the outside world and from each other. They need a temperature-controlled environment to keep them in an optimum operating range. Too cold and the chemistry gets sluggish, and too hot and the battery begins to degrade. They also need to be protected against their neighbors. Small differences between individual cells need to be balanced out with protection circuitry that keeps them from charging and discharging each other. The batteries heat up when they are charging or discharging, with fast charging being the worst case scenario. The best battery packs are liquid cooled to control the temperature of the cells. The size of the cells has been somewhat limited in part just due to the ability to transfer heat in and out of the cell, but there's been a steady progression to larger cells, mostly driven by Tesla. The current batteries used are 1865 and 2170 batteries, which are 18 and 21 millimeters in diameter and 65 and 70 millimeters in length, respectively. The internal construction of these batteries dictates that the heat needs to be primarily transferred in and out of the battery through the sides of the battery, which limits their diameter. As you can see in these images, a cooling snake is woven between the batteries, which consists of an extruded aluminum strap with internal channels through which coolant is pumped. As you can also see, the cooling snake is generally only contacting the batteries along one side, resulting in asymmetric heat transfer, which will leave some portions of the battery warmer than others. Obviously, this approach is working for Tesla and other people, but it isn't ideal. And by the way, Aptera will be using the 2170 batteries in their packs. The new 4680 battery is the latest battery design from Tesla. It has an internal shingle construction that appears to have small tabs or shingles at the ends of the battery layers so that they roll over on each end. And this helps transfer the heat and power to the ends of the battery case and also eliminates an internal tab that transfers power out of the cell, which was also creating a thermal resistance at the ends of the battery. The end result is a larger battery that has 5x the capacity and can deliver 6 times the power. This translates to an increase in range and shorter charging times. The cooling snake can now be replaced with a cooling plate at the top or bottom. But Tesla's gone a step farther. They're potting these batteries in epoxy to create a monolithic block that can transfer the shear stresses through the pack to the cooling plates on the top and the bottom, which are now pulling double duty as cooling plates and structural members of the car chassis. You think of a battery pack as an I-beam you might see in your basement holding up your house. The top and bottom flanges of the beam are the cooling plates, and the vertical web that connects them is the battery pack. I can think of several technical challenges surrounding the expansion and contraction of the batteries and the cyclic loading of the chassis as it flexes, but I trust Tesla's address these potential problems. The 4680 battery is also less expensive to manufacture and uses less cobalt and water, which leads to less expensive cars and less impact on the environment. Although the Tesla 4680 battery is a big move forward, solid-state lithium batteries are generally acknowledged as the future battery of choice. The difference between the current lithium-ion and solid-state batteries is that the solid-state battery uses a solid lithium metal and a solid separator between the anode and the cathode. The key challenge has been to develop a solid-state separator that doesn't allow the growth of conductive dendrites that can cause the two to short. Both polymer and ceramic separators have been tried, and batteries have been produced in the lab on a small scale, but scaling up to production volumes is a challenge. The main players in this space are QuantumScape, which is partnered with the Volkswagen Group, and Toyota. There are a lot of other minor players in this space, but these two seem to be out in front. It's difficult to say when these batteries will come to market. My best guess is about 2 to 3 years, and when they do arrive, it'll be the next big step forward for electric vehicles. The Aptera costs half as much to build as other vehicles. This is a result of a low parts count, a smaller battery, and lower tooling costs that are typically amortized into the price of the car over the years. In any electric vehicle, the most expensive line item on the bill of material is the battery. And given that the Aptera is 3 times as efficient, you can get by on a battery 1/3 the size of a typical electric vehicle. That means a major cost item in the Aptera is 1/3 that of a typical electrical vehicle. And once again, you see that the efficiency pays dividends in different ways that you wouldn't expect. Although the car's unique shape can give the impression it's small, it's actually similar in size to the Tesla Model 3 or Toyota Prius. However, that perception can lead to concern about safety. The composite monocoque chassis is inspired by the safety cell in a Formula One race car. Back in 2009, the original Aptera posted a rollover crush strength 6 times stronger than any car ever tested. What was surprising to the founders was that after the roof finally crushed, it popped right back into shape after the force was removed. The egg shape does an excellent job of distributing the force of an impact. And in case you're wondering, it does have airbags. Aptera uses only 4 major structural parts compared to Tesla's 200 parts. In any product, every single part adds cost and complexity and reduces reliability. And by drastically reducing the parts count, Aptera can lower costs and increase reliability. Also, these composite parts are made on inexpensive 3D printed tooling with a vacuum infusion process instead of requiring extremely expensive sheet metal stamping tools. The parts are all light enough to be picked up by 2 people and snapped together like Legos while the structural adhesives are curing. This means fewer assembly fixtures, fewer robots, lower capital costs, and the ability to expand production capacity as fast or as slow as necessary to respond to demand. It also means that Aptera will create jobs for people. One of the founders' goals is to create good jobs for people, jobs that are challenging, engaging, and require skill. And something else to consider, Aptera is going to essentially be a hand-built car along the lines of a Bentley, a Ferrari, and Bugatti, built by artisans, not workers. From that perspective, it might be surprising to learn that a hand-built Aptera can be purchased for $26,000 to $46,000, depending on the range and the options selected. Aptera has already produced 3 working alpha vehicles and intends to produce what they refer to as a production intent vehicle by the end of the year and begin shipping their first production cars to customers in early 2022. Moving this fast seems impossible until you consider they're using 3D printing to create their tools and fixtures instead of expensive milled and hardened tools required for sheet metal construction. In a recent investors meeting, they revealed that they've released all of the major tools for the composite body for fabrication, as well as all the front suspension parts and glass for the beta version vehicles. At the moment, they appear to be on schedule to deliver their first production intent vehicle before the end of 2021. However, supply chain issues have been negatively affecting all industries, including the EV industry, so I would not be surprised to see some small delays. Integral solar power is one of the major differentiators of Aptera compared to its competitors and can provide up to 11,000 miles of range per year, or approximately 40 miles per day. Given that the average commute in the US is less than 29 miles, most people will never have to charge their car depending on the solar package they order and where they live. As Floridians, I think you can expect the full 40 miles of free range per day. Solar panels have been embedded onto other cars in the past and the present, but since those cars are much heavier and less aerodynamic, their solar cells only provide very small amounts of additional range and amount to little more than a marketing gimmick. The solar panels are removable so they can be replaced and upgraded in the future as solar cell efficiencies continue to rise. Also, the Aptera can be charged from the typical 110 volt outlet found in most people's garage and provide 13 miles of range per hour of charging. This eliminates the high cost of running a 220 volt high current line required by most other EVs. Once again, that efficiency is paying dividends in ways you don't anticipate. If and when your Aptera needs a repair, a trained service technician will come directly to your home to make the repair. This is the Tesla service model that's been working very well for them. However, different from Tesla, Aptera plans to embrace the right to repair philosophy. This means that if you choose to repair your own vehicle, they'll provide schematics, drawings, step-by-step service procedures and videos, and ship parts directly to your home overnight. This can translate into drastic savings after the car's out of warranty. And frankly, many people consider this to be one of the biggest selling points for the Aptera. Got some miscellaneous facts. Because the Aptera has 3 wheels instead of 4, it registers and insures as a motorcycle in most states. This is yet another source of savings compared to a 4-wheel car. The composite body is made up of a blend of fiberglass, Kevlar, carbon fiber, and hemp. Yeah, I said hemp. Aptera has a long-term goal to use organic resins and natural fibers so that when the car is at end of life, it will decompose when underground. However, the current composite body is immune to rust and should last indefinitely. A car designed to last 40 years or more means a 4x to 8x energy and resource reduction compared to your standard ICE car built on a 5 to 10 year platform. That's a huge benefit for the environment. The finish on the body is a vinyl wrap instead of paint. Painting a car is kind of an environmental nightmare, and the vinyl eliminates the VOCs released in the painting process and can be easily customized or refreshed periodically. The hub motors and batteries are liquid cooled, and Aptera uses coolant lines embedded in the skin of the car instead of a radiator in order to preserve the aerodynamics. Since the car is so efficient, the motors and batteries do not dissipate as much heat as other EVs. Yet another unexpected benefit due to efficiency. The hub motors can turn in opposite directions, which makes tank turns possible if you're into that. The logos on the front and the sides of the car glow at night and look really cool. Aptera calls them glogos. They're seriously considering vehicle to grid charging in the future. Although the business case for this is not clear, the potential of millions of electric cars serving as storage to the grid to provide peak power could reduce power plant emissions by as much as 30%. And lastly, a Tesla charging port is shown in most of the recent videos, which implies that they may gain access to the Tesla charging network, which would be a big selling point for a lot of people. That isn't confirmed yet, though. This is the spec sheet for all of the current options for your Aptera. The prices ranges from 25,900 to 46,000, depending primarily on the range option you select, and to a lesser extent, the options you add on. The Aptera is currently offered in 3 colors: white, black, and silver, and 3 interior color schemes. And you can also opt for a custom color. You can add on Safety Pilot, which is a level 2 autonomous driving, a high-end audio system, and a camping package, which turns the back of the Aptera into sleeping quarters for 2 adults. There's a pet package to confine your pet to the back hatch area, and an off-road package that provides higher ground clearance and more durable wheel pants. But your biggest decision will be the size of the battery and the range. The least expensive is a 25 kilowatt battery that will provide 250 miles of range, approximately equal to the Tesla Model 3, but at a substantially lower price point. The 400-mile variant is currently the most popular, but you can also choose larger batteries that will provide 600 or even 1,000 miles of range. I personally chose the 600-mile version so that I can drive 5 hours to northern Wisconsin from the Chicago area at high speed without having to stop to and really makes a statement.
Are we still going? Is that it? Is that your last slide? Oh, are you still with us, Jeff? Can you guys hear me? Okay, so Jeff, we can't hear you. Let me ask him to start his video. Oh, I think he has to, nope, he's still, Jeff, we can't hear you. Ask him to unmute. Jeff, are you there?
I'm still here.
Okay, we couldn't hear the last, but now we can see you. So
Okay.
that was your last slide? I think so. We're ready
Pretty close to it. Yeah.
I think we're ready for questions, right, everybody?
Okay.
Because, oh my God, there's a lot of information. And we're not trying, our idea is not to sell an Aptera, even though, were you able to show like some of the, you can talk, they're actually coming up with other um, cars, right, that are going to be bigger.
Yes, they have a plans next for a 5-passenger sedan. Their strategy is to focus on the Roadster because being 3 wheels, it doesn't have to meet as many requirements for the transportation department. So they can get this out the door quickly, get some revenue in, and then dedicate that revenue to designing other cars, which will move up in size, through a sedan, an SUV size car, eventually to vans as well.
Yeah. I wrote, so everybody, let me know if you have a question. I just wanted to ask this really quick and then I'll leave it to everybody. So, I was looking at the videos and how lightweight the car is. Now, here in Florida, we have hurricanes and hurricane force winds. And is this saying that everybody's going to have to put it in a garage? Can they handle the gusts? Are we going to roll around? Because you talk about how lightweight it is. And I think a lot of us feel safe in these heavier vehicles. We see boats flipping and turning and other cars. How how are we going to do if we if I get a solar vehicle and a hurricane comes and I park my Aptera in the driveway? Is it going to be there the next day?
My guess is that if you get hit with a hurricane, it may be down the street a little bit. That's a very extreme scenario. A lot of
But
people do have concerns over something more common, like a large semi driving past you and leaving a wake, or a crosswind. And the the answer to that is that the car is very aerodynamic, not just from the front, but from the sides as well, so that it's very steady in the wind. But in
Okay.
a
So,
hurricane, I think all bets are off.
yeah, so that's gonna hurt me if I get one, and I only have a one-car garage, and everybody knows my Jeep is in the garage right now, and I don't, my Tesla's outside. Does anybody have any questions for Jeff regarding the future of yes, Mrs. Rice, do you want to unmute yourself? If
Okay.
just hit,
Okay, can you hear me?
yes,
Okay.
ma'am.
I'm very familiar with solar panels, having had a 40-foot sailboat that we sailed the Caribbean with, and they are incredibly efficient. We ran our entire boat and all the mechanisms on it, the freezer, the refrigerator, the water maker, the heater, everything on it. It was marvelous. Of course, we had 6 panels on board, and we had the full sun every day. How much storage do you get? You say you can go 40 miles a day. Suppose the car sits there for 3 days. Does it hold that storage in the batteries?
Yeah, a lot of people are confused. The car has got a large battery. The smallest battery is the 25 kilowatt battery. But if you were to leave it in the sun for 3 days, it's going to pick up 120 miles of range at 40 miles per day. And it'll continue to charge as long as it's sitting there in the sun until it tops out the battery. But it's able to be charged, like any other electric vehicle. I think the real differentiator here is that this vehicle, for most people's daily driving needs, won't need to be charged, plugged in. The solar will give everything you need. But if you're going to make a long trip, you might want to top it off, in the garage. And the other thing I mentioned was that most electric vehicles require a very high current 220 volt line to be run, which it can cost a couple $1,000s for an electrician to run that.
Yeah.
This just plugs into the wall, like any outlet, and you can get 13 miles per hour. So if it stays there for 10 hours on charge overnight, you're going to get 130 miles by the morning.
Thank you.
So we can't just drive this Aptera in the sun and just go, 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 go. So it doesn't like charge while we're driving it, right?
It is charging, but it is charging while you're driving, but you're consuming more than the panels are putting out. So you're still going to lose range, but it doesn't stop collecting when it's driving, when it's moving.
Will your larger cars be able to have more panels on them? Or that wouldn't matter, because if the battery is a certain size, that's it?
No, the battery is not the limiting. It's really the surface area on the car. So a larger car would be able to accommodate more cells. But cars are only so big. I don't think you're going to see a big jump in power generation, just a small jump.
Thank you.
The cells that they're using, there was just a video today. One of the founders was showing them, and they're 24% efficient, as you're mentioning. They're very efficient now, and they're made with a technology that is called powder technology. And so he broke one, and amazingly, he said that even if it were to break, it continues to generate almost 100% of the power that it can. So it's pretty amazing.
Amazing.
Mr. Rosenbaum?
I should say though that the
sorry, we have Mr. Rosenbaum wants to get in a question real quick.
all right, I just should say that the solar cells are covered by a clear panel, so that if you get caught in a hailstorm or a rock gets thrown up, it's not going to directly hit the solar cells and break them.
Okay, so I can go.
Yep.
Yeah. So I've been following Aptera for 15 years. I tried to order one right after they won their award, probably about 10 years ago, and then they disappeared. Your slide showed that they sold off to a Chinese corporation. what makes you think that they're going to be able to come to market now, 10 and 12 years later, and sell out of state? I was told I couldn't put an order in, having lived in New Jersey at the time.
Were you told that you can't put an order now or back then for New
Back
Jersey?
then.
Okay, I think that's no longer true. But they will say that the big difference between then and now is that a lot of the components that they're using on the Aptera, the EV market has just advanced in that time, so that everything they had to do back then was a research project. You know, they had to invent the motor, invent everything, you know, all of the motor controllers, everything had to be from the ground up. Now they can kind of just go shopping. You know, they go to a company that's making motor controllers. They're going to a company in, I believe, the Czech Republic called Laffy to buy their hub motors. You know, Chris Anthony had the lithium ion battery pack company, so he's got a lot of knowledge on how to build a battery pack. So that, but they're able to use the 2170 batteries that were developed by Tesla. And I want to make it clear, I mean, I did a lot of comparisons to Tesla today, and it may have come off that I was picking on them. I do not want to say that at all. I love Tesla and I love Elon Musk. He's great, and he takes a lot of risks, and he's on a mission. And he's been a first mover and provided a lot of the infrastructure, you know, in terms of batteries and controllers and just everything. And Aptera is leveraging a lot of that. And so that's the difference, is they're leveraging a lot of technologies that have advanced in the meantime from 9 years ago.
So are they going to be able to pass safety tests with this car out on highway driving or intercity driving?
Yes. While they do not have to, because they're considered a motorcycle, they plan to pass all of those tests. I believe there's some over 700 requirements for like a four-door sedan, and they plan on passing all of those. As I mentioned, I think you probably already know, you were watching them back 15 years ago. That car, that shell, was incredibly strong. It was 6 times higher than the crush strength, and it's going to tend to bounce more than crush. You know, you get hit by steel, or a steel car gets hit, it crushes, and they do have crush zones, crumple zones on the front and the back. Side impact, they don't have that, but they do have airbags to protect you inside. So I think it's probably going to be one of the safest cars out there, but I can't really make that statement until they complete their testing.
But you do think they're going to come to market at the beginning of next year?
Their schedule, the stated schedule, is to produce beta vehicles, and then they've got a couple other levels, some Delta and Gamma, but they are planning to produce what they call a production intent vehicle, which is basically what they would ship by the end of this year. Now, I think things are slipping, but they haven't said that yet. But I think they're slipping primarily because there's a lot of difficulties in the supply chain right now, and everybody's suffering with that. So they may get set back a little bit, but their goal is to begin shipping first quarter of 2022. So we're talking 4 months, you know. We'll
So
see.
if I buy one, Mr. Rosenbaum, you know, I'll share it with you and we can put it in your garage, okay? I hope you have one.
Except I don't have a garage in Gleneagles. It's outdoors.
Oh, we have to figure something out, because that would be really cool. I was actually gonna reserve one, because you know it's not much, and it would be really cool to drive around the A1A on one of these.
100%.
Yep.
On the old Jay Leno movie or video back in the day when they first had the Aptera, he was commenting that as he was driving around in Los Angeles, that everybody was pulling up next to him in traffic and videoing or taking a picture with their cell phones. So you'll definitely draw attention with this car. You make friends.
Yeah. Anybody else? Mrs. Golden, do you have any questions?
Yeah, I do. Is this company listed on the stock exchange?
It isn't. And if you're interested, they are open for investment. Maybe I should probably do a disclaimer here. I am an investor in Aptera. They are another thing they're doing differently than other startups is that in the past, I think a lot of you have been frustrated by this. You'll see like a Facebook or somebody who's doing a startup, and it's only open to the fat cats on Wall Street. The big banks get in there, they buy all that stock. It goes sailing up when they go IPO. They get rich, and then the rest of us are just picking up scraps. Aptera is open for investment right now at $8.80 a share.
Wow.
And they have plans to go IPO in 12 to 18 months. They hired a woman, I can't remember her name, as CFO who specializes in taking companies IPO. And if you look at some of the valuations of the other electric car companies that are out there, they're being treated as tech companies, got ridiculously high valuations. So Aptera could be just a spectacular investment if you were to put some money in. And the minimum investment's $1,000 with them, so you don't have to take a giant risk.
Can you send the information for investing to Tammy so we can get it from her?
I can, but if you just go to the website, I think that it's right on there. So
How
we take
is
credit cards.
how is it that you have a car now?
Oh, he does.
Oh, I don't have a car.
You don't? Okay.
He wishes he had a car.
Yeah, I have a reservation for a car. I probably won't receive my car until the end of next year. I didn't get in.
I'm a bit of a cynic. Many years ago, I drove a Volkswagen, got 30 miles per hour, and I'm driving a car now that I don't even get 30 miles an hour. Who's going to stop this? Will somebody stop the production? We are so far beyond. So many years have gone by. Why hasn't fuel economy gotten better?
Well, there's just limits on internal combustion engines. They've kind of done everything they can do with them, and they're just not going to get much better from here on out. They've squeezed everything they can out of them. There's just thermodynamic limits that they just can't violate. Electric vehicles are a different animal, and they're operating at more like in the 80% efficient range compared to like 23% for internal combustion engines. So you're exactly right. In fact, I remember back a Geo Metro that was getting 52 miles per gallon with a 3-cylinder engine, and somehow it seems to have gone backwards since then.
Thank you.
So if you're an investor, do you get first dibs on a car? And how come yours is so late in the year next year?
You, just like everybody else, I'm in line. I put my $100 down. I can't remember what my number is, but I'm somewhere out in the like 9,000s, I believe.
Oh,
And
God.
I'm not, I'm not upset about that, because as an engineer, I know it's better to let them have some time to work out some of the kinks. So I'll take one that's down the road a little bit.
And if you want, I have a link I can send you guys, because I went last night to go see what it was like ordering an Aptera, because it's just like buying my Tesla. You pick out the colors, you do this, you do that, you get your price tag, and and I did his, and you get you can sign up to get one for $70, not $100, because you used Jeff's link. So I told my boyfriend tonight, I'm like, after the talk, I'm like, by the time maybe I get my soul, maybe by the time I'm the 80,000th customer, I might be able to afford it, and I'll have my house with a 5-car garage and be able to keep it there. But yeah,
Yeah, I think the last time they have, last I heard is they're just over 13,000 pre-orders,
no, that's
and
not
that
bad.
represents like 400 million of revenue in the future. So you don't have to wait past 13,000 at least.
Okay, sounds good. But you don't think anything else is going to come along in the process? You think Aptera, if myself searching and stuff for companies, Aptera is right now, they're pretty much, are they the sole leader in solar vehicles here in the States? Besides the ones that
Yes.
you mentioned, yes.
In fact, some of the other vehicles I talked about, the Lightyear One and the Sono Scion, it's questionable whether those will even come to the United States, and if they do, it could be many years before they come to the United States. And as I was, showing in some of those bar charts, is that they are so far out in front of everything out there right now that it's just hard to believe that anybody would be able to catch up with them without pretty much copying what they're doing. So I
And
don't
Steve,
think they're going to have much competition for this foreseeable future.
so Steve Fambro and Elon Musk, they're pretty tight, right?
I don't really know. I think they've had some discussions, particularly about the charging network. There may be some tech that they're leveraging. A lot of people have noticed that some of the parts that you see on the interior of the Aptera seem to be borrowed from Tesla. So I don't know exactly the extent of their relationship, but I think they're talking.
All right. Well, thank you so much, Jeff. I appreciate you taking the time and, with all the back and forth emails, and I will definitely tell Aptera how valuable. Oh, wait a minute, Mr. Saxena, you have a question, sir? Oh, we can't hear you. Oh, wait a minute. Yeah, I can't hear you, sir.
Um, can you hear me at all?
Yes.
I was going to ask Jeff, what is the carbon footprint of one of their vehicles?
The carbon footprint
Jeff,
of the entire car?
yes, Jeff, I mean, you
I don't have a number to place on that. What I would say, and I'm thinking about in terms of manufacturing it, the biggest impact is that the car can't rust. And I mean, it's a car that you could buy and refresh over the years and could last literally indefinitely.
I don't think we answered his question. Mr. Saxena, we can't hear you because I think you and your wife are next to each other and there's a little echo. So if you want,
I will go away and
hang on, yeah, you have to either go to your wife's or go to another room so we can hear you.
yeah, Tammy, can you hear me better?
You're a little echo. I don't know if you're covering the microphone on your phone or something, but
Okay, let's try again. Or
that's
we
better.
can, yeah, this is good.
Yes.
Jeff,
Talk, we can hear you.
hello, Jeff.
Yes,
Yep.
I can hear you.
The question I had really, I'm a material scientist, and the question I had really was whatever you do, you have to have steel, you have to have aluminum, and these are to be produced by what technology? Because every technology that gives you steel has such a high carbon footprint that we are pretty, I don't know your Aptera might. I just was curious. I'm of course very jealous that you have been able to work with a solar system, and we tried to use solar power in creating some of creating one of these metals without using coal and carbon. But in this case, it would be the solar panels. Solar is, of course, who can argue with motherhood, and it is a wonderful technology. But will it really will it really affect the environment?
So
And how much damage will we continue to do in terms of carbon dioxide?
I think the gist of your question is, you mentioned that there has to be aluminum and steel parts. And there are some of those parts that are used on the suspension. But as a material scientist, you realize there's good materials for certain applications. And so they're using a little bit of metal where it's best suited. But on the overall chassis, they're currently using fiberglass and Kevlar and a little bit of hemp. And long term, they plan to try to emphasize more of the natural fibers like hemp and organic resins. But in regards to the metal components, they're also using generative design, which is a way, it's kind of like you give a space that is allowable for a part to exist in, and you put the constraints of the loads and the constraints on it, and then the computer will find an optimum shape that ends up looking quite a bit like the bones in our body, very organic. And what that does is it minimizes the amount of metal being used. So it takes that carbon footprint down to an absolute minimum. But there's you do need to use some steel and some aluminum here and there.
Oh, sorry, we had to mute you because of the feedback. So you can unmute yourself, Mr. Saxena.
Yeah, sure.
Okay.
Thank you so much.
Thank you for joining us. All right, well, everybody, I think that does it for tonight. Thank you. And if you guys have any questions or if you want any extra information, I can pass along Jeff's information to you or vice versa. And hopefully maybe next year, by the end of 2021, you'll see me driving to work in my new Aptera.
Wonderful.
All right, everybody, have a great evening.
Yeah.
All right. Thank you.
Thank
Bye, Jeff.
you.